I'm going to talk today about energy and climate. And that might seem a bit surprising because my full-time work at the Foundation is mostly about vaccines and seeds, about the things that we need to invent and deliver to help the poorest 2 billion live better lives. But energy and climate are extremely important to these people. In fact, more important than to anyone else on the planet. The climate getting worse means that many years their crops won't grow. There'll be too much rain, not enough rain. Things will change in ways that their fragile environment simply can't support. And that leads to starvation, it leads to uncertainty, it leads to unrest. So the climate changes will be terrible for them. Also, the price of energy is very important to them. In fact, if you could pick just one thing to lower the price of to reduce poverty, by far you would pick energy. Now, the price of energy has come down over time. Advanced civilization is based on advances in energy. The coal revolution fueled the Industrial Revolution, and even in the 1900s, we've seen a very rapid decline in the price of electricity. That's why we have refrigerators, air conditioning. We can make modern materials and do so many things. And so we're in a wonderful situation with electricity in the rich world. But as we make it cheaper, and let's go for making it twice as cheap, we need to meet a new constraint. And that constraint has to do with CO2. CO2 is warming the planet. And the equation on CO2 is actually a very straightforward one. If you sum up the CO2 that gets emitted, that leads to a temperature increase. And that temperature increase leads to some very negative effects. The effects on the weather, perhaps worse, the indirect effects in that the natural ecosystems can't adjust to these rapid changes, and so you get ecosystem collapses. Now, the exact amount of how you map from a certain increase in CO2 to what temperature will be and where the positive feedbacks are, there's some uncertainty there, but not very much. And there's certainly uncertainty about how bad those effects will be, but they will be extremely bad. I asked the top scientists in this several times, do we really have to get down to near zero? Can't we just cut it in half or a quarter? And the answer is that until we get near to zero, the temperature will continue to rise. And so that's a big challenge. It's very different than saying, we're a 12-foot high truck trying to get under a 10-foot bridge and we can just sort of squeeze under. This is something that has to get to zero. Now, we put out a lot of carbon dioxide every year, over 26 billion tons. For each American, it's about 20 tons. For people in poor countries, it's less than 1 ton. It's an average about 5 tons for everyone on the planet. And somehow we have to make changes that will bring that down to zero. It's been constantly going up. It's only various economic changes that have even flattened it at all. So we have to go from rapidly rising to falling and falling all the way to zero. This equation has 4 factors, a little bit of multiplication. So you've got a thing on the left, CO2, that you want to get to zero. And that's going to be based on the number of people, the services each person's using on average, the energy on average for each service, and the CO2 being put out per unit of energy. So let's look at each one of these and see how we can get this down to zero. Probably one of these numbers is going to have to get pretty near to zero. That's back from high school algebra, but let's take a look. First, we've got population. The world today has 6.8 billion people. That's headed up to about 9 billion. Now, if we do a really great job on new vaccines, healthcare, reproductive health services, we could lower that by perhaps 10 or 15%. But there we see an increase of about 1.3. The second factor is the services we use. This encompasses everything: the food we eat, clothing, TV, heating. These are very good things. Getting rid of poverty means providing these services to almost everyone on the planet. And it's a great thing for this number to go up. In the rich world, perhaps the top 1 billion, we probably could cut back and use less. But every year, this number on average is going to go up. And so overall, that will more than double the services delivered per person. Here we have a very basic service. Do you have lighting in your house to be able to read your homework? And in fact, these kids don't, so they're going out and reading their schoolwork under the street lamps. Now, efficiency, E, the energy for each service, here finally we have some good news. We have something that's not going up. Through various inventions and new ways of doing lighting, through different types of cars, different ways of building buildings, there are a lot of services where you can bring the energy for that service down quite substantially. Some individual services even bring it down by 90%. There are other services like how we make fertilizer or how we do air transport where the rooms for improvement are far, far less. And so overall here, if we're optimistic, we may get a reduction of a factor of 3 to even perhaps a factor of 6. But for these first 3 factors now, we've gone from 26 billion to at best maybe 13 billion tons. And that just won't cut it. So let's look at this 4th factor. This is going to be a key one. And this is the amount of CO2 put out for each unit of energy. And so the question is, can you actually get that to 0? If you burn coal, no. If you burn natural gas, no. Almost every way we make electricity today, except for the emerging renewables and nuclear, puts out CO2. And so what we're going to have to do at a global scale is create a new system. And so we need energy miracles. Now, when I use the term miracle, I don't mean something that's impossible. You know, the microprocessor is a miracle. The personal computer is a miracle. The internet and its services are a miracle. So the people here have participated in the creation of many miracles. Usually we don't have a deadline where you have to get the miracle by a certain date. Usually you just kind of stand by and some come along, some don't. This is a case where we actually have to drive at full speed and get a miracle in a pretty tight timeline. So let's think, how should we measure ourselves? What should our report card look like? Well, let's go out to where we really need to get and then look at the intermediate. For 2050, you've heard many people talk about this 80% reduction. That really is very important that we get there. And that 20% will be used up by things going on in poor countries, still some agriculture. Hopefully we will have cleaned up forestry, cement. So to get to that 80%, the developed countries, including countries like China, will have had to switch their electricity generation altogether. So the other grade is, are we deploying this zero-emission technology? Have we deployed it in all the developed countries, and we're in the process of getting it out elsewhere? That's super important. That's a key element of making that report card. So backing up from there, what should the 2020 report card look like? Well, it should have the 2 elements. We should go through these efficiency measures to start getting reductions. The less we emit, the less that sum will be of CO2, and therefore the less the temperature. But in some ways, the grade we get there, doing things that don't get us all the way to the big reductions, is only equally or maybe even slightly less important than the other, which is the pace of innovation on these breakthroughs. So this is a wish. It's a very concrete wish that we invent this technology. If you gave me only one wish for the next 50 years, I can pick who's president, I can pick a vaccine, which is something I love, or I could pick that this thing that's half the cost with no CO2 gets invented. This is the wish I would pick. This is the one with the greatest impact. If we don't get this wish, the division between the people who think short-term and long-term will be terrible, between the US and China, between poor countries and rich, and most of all, the lives of those 2 billion will be far worse. So what do we have to do? What am I appealing to you to step forward and drive? We need to go for more research funding. When countries get together at places like Copenhagen, they shouldn't just discuss the CO2, they should discuss this innovation agenda, and you'd be stunned at the ridiculously low levels of spending on these innovative approaches. We do need the market incentives, CO2 tax, cap and trade, something that gets that price signal out there. We need to get the message out. We need to have this dialogue be a more rational, more understandable dialogue, including the steps that the government takes. This is an important wish, but it is one I think we can achieve. Thank you.